Okay guys, I'm going to work through the Practice Masters Level A with you guys just to give you a little bit more review of the parabola. And we're going to start this first section by writing the standard equation for the parabola, that's graph. So the first thing I need to think about is the fact that this opens up. So this is going to be in the form y equals x squared. But I need my vertex, which is going to be 0, 3. So sometimes it helps to write that out. So it's going to actually be y is equal to x squared plus 3. So it's almost like you have x minus 0 all squared inside here. Okay, so that's how you would do it. Now, the only thing I haven't taken into account is the fact that my focus is located at 4. So what that means is this length here is a 1. So P is equal to 1. And there's a little thing that if you know P, you can just say A is equal to 1 over 4P. And if P is equal to 1, it's just going to simplify down to 1/4. So it's going to actually be y is equal to 1/4 x squared plus 3. So that's how we're going to do that one. Okay, the next one opens down, and the vertex is at 0, -2. So 0, -2. And I know that it's going to be in the form y equals -x squared. So I'm just going to say y is equal to, and I'll come back and do the negative in just a second. And then I have x squared minus 2. And I need my length of P, or my distance for P, and it looks like it's going to be just a 1 unit. So again, it's going to be A is equal to 1 over 4P. And P is actually, if you want to think of it like a -1 because you're going down, it's going to be a -1/4. So that's how that would look. Now the next one. So on the next one we know it opens up, so again in the form y is equal to x squared. The vertex is located at -3, -1. So I like to write that out. So I'm going to say y is equal to, and then it's going to be x plus 3 all squared minus 1. So there's the -3, -1. And on this problem, I have the directrix at -3. So I'm going from -1 down to -3. So the distance here is 2. So P is a 2, meaning A is 1 over 4 times 2, or 1/8. So it's going to be 1/8. And it opens up, so that makes perfect sense. So those are the 3 first ones. So let's label, graph each of these equations, label the vertex, focus, and directrix. So let's do these next few. So my center here is going to be at 0, 0. So I need to label that. And A is 1/8. So P is going to be 1 over 4A. And then, of course, it's just a 1/8. So 1/8. So it's going to be 1 over 4 over 8, because I multiply 4 times 1 over 8. So it's going to be 4/8 or 1/2. Now the way this simplifies down is that P is actually going to be 2, because it's going to be 1 times the reciprocal. So there's where I get the 2. So if P is 2, this opens up. I've got to go up 2 for the focus, so that's going to be F. Then I've also got to go down 2 for the directrix, so this is going to be y equals -2 for that. Now, for the focal width, what we call focal width, it's going to be 2, which is our focal length, times 4. So it's going to be 8 long, so I'm going to go 4 to the left, 4 to the right. So this is actually our focal width of 8. This is our focal length of 2. So that's kind of how the relationship works. So it's going to graph up like this and through that. Okay, let's do the next one. Now this one is going to open to the right because it's x equals y squared, and this is positive. So my center is at 0, 0 again, and P is going to be 1 over 4A. And I'm putting in the A here. So this is going to simplify down to 1 over 4 over 12, which is going to be 1 over 3. So this is going to be 3. So now I'm going to go 3 to the right for my focus and 3 to the left for my directrix. So this is going to be the line x equals negative 3. Now the focal width is going to be, if this is going to be 3, this is going to be 4 times that. So that's going to be 12, which means I'm going to go up 6 and down 6. So it's a very, very wide parabola because it's being basically compressed, making it kind of, I didn't draw that very well there, but looks something like this. Okay, so let's look at the next one. So I have a little bit of work to do on this one. Let me kind of erase this since it's, you already know this is 3. So I'm going to add the 2 to the other side because that's how we've learned this. So it's going to be y equals 1/4 and then x plus 2 squared plus 2. So my vertex here is going to be negative 2, 2. So negative 2, 2. There's my vertex. And this is going to open up because it's y equals x squared. And my p-value is going to be 1 over 4a, and this is 1 over 4. So I just plugged in my a value, so I get 1 over 1. So it's going to be 1. So it's going to go up by 1 for the focus, down by 1 for the directrix. So that's going to put the directrix, when we were at negative 2, 2, it's going to put it down 1. So it's going to be a y of 1. And sometimes it helps to write the vertex out. So negative 2, 2. And remember that for this, because it opens up, we're going up 1. So that would be a focus at negative 2, 3, which is what we have here. And a directrix, which would go down from the 2 and put us at x equals 1. So this is our directrix. All right, now what about the width? So we know p is equal to 1. That means the focal width is just going to be 4. So I go to the focus, that's why it's called focal width. I go 2 to the right and 2 to the left. And it's going to look something like this. Okay, now the next little section sort of talks about some clues that we have. So if we have a vertex at 0, 0, I'd probably just do a little sketch. A vertex at 0, 0. And then the focus is at 0, 5. So 0, 5. So that basically is telling us this parabola has to open up, meaning it's in the form of y is equal to x squared. Now, it's at 0, 0, so that makes it pretty simple. So it's going to be x squared. But I still need my a value out front. And this is saying that p must be 5. So p is 5. So this is going to be 1 over 4 times 5, or 1/20th. And that's how you're going to do that one. And you don't actually have to graph it. You just have to write the equation. Okay, the next one is located, the vertex is at 0, 0. I'll move this guy over here. 0, 0. And then the focus is at negative 4, 0. So over here. So what this is saying is that this one must open to the left, because the focus is always inside the parabola. So just sketch it and see what you have. It's also saying P is 4. Okay? So I'm going to basically say this is an x equals, I know it's going to be negative because it's opening left, and then I'm going to have y squared. So how do I figure out the a value? Well, it's going to be a negative 1 over 4 times 4, so 1 over 16. So that'd be the equation there. Now, I drew this one. This would probably be a lot wider because the focal width would be 4 times 4, or 16. So it'd be a little bit wider than what I drew there. Okay, so that's how you approach those. Let's do 9 and 10. Okay, so we have a vertex at negative 3, 0. So negative 3, 0. And we have a directrix at x equals negative 6. So kind of giving us a little bit different information here. So here's the vertex, negative 3, 0, and x of negative 6 is the directrix, so right here. Now why that's important is the distance between the vertex and the directrix here is 3 units, okay? So that's basically saying P is 3. Now, it's also saying if this is the vertex and this is the directrix, it means it has to open to the right. So that's how this one's going to open up, kind of to the right like that. Meaning that it's going to be an x equals y squared, but it's going to be a positive value out front. Okay, so the vertex is at negative 3, 0, so I'll take that into account. So I'm going to say y minus 0 squared minus 3. So I want to write the 0 in here because this one's kind of confusing. So if I were looking for the vertex of this, remember you go to the x to get the x. You do not change the sign, so it's just a negative 3, 0. And it's positive, so it's just going to be 1 over 3 times 4, or 12. So that would be the answer there. Okay, let's do another one. The vertex is at 0, 4. And so it's going to be right about there. And the directrix is at y equals 9. So I'm going to erase this just to kind of show you. So 0, 4, and then I'm way up here at y is equal to 9 for the directrix. So that means with this vertex and this directrix, this one has to open downward. And it's also telling us that if this is 0, 4, I'm going up by 5, so P is 5. Okay, and I know that this is going to have a negative Lie coefficient, but it's going to be in the form y equals negative x squared. So writing this one out, I'm going to have y equals, and then I can go ahead and put my p in place. It's a negative 1, 4 times 5 is 20, and then I'm going to say x minus 0 squared plus 4. So again, kind of check your work here. This would be 0, 4. Remember that you always go to the x when you're trying to find the x for the vertex, and you change the sign in the parentheses and you keep the sign outside. So this would be 0, 4, and then just looking at this, I know I'd have a P of 5. Now, the reason I made it negative is because this must open down, because this is the vertex and the directrix is always kind of, like, think about it would, like, if you backed into it, kind of back into this. So the focus must be, in fact, the focus would be right there at 0, -1. Okay, so I think that probably gets you started on this. These are kind of the same type of approach. So let's look at the next page. Oh, I'm pushing the key here. Okay, so here's B. Now, B gets a little bit harder, but I know we'll do just fine here. So this one is going to open up, so in the form y equals x squared. The vertex is at -2, 4. And it looks like P is a unit of 1. P is 1. So this is simply going to be y is equal to 1 over 4 times 1, because I'm just using that P there. And then that's going to be x plus 2 all squared plus 4, like that. So that would be that equation. So the vertex, -2, 4, matches what we have here, and then our p-value is a 1. Okay, this one opens to the left, so it's going to be in the form x equals -y squared, and the vertex is going to be, looks like -5, 3. And it looks like our p is 2. Or -2 if you want to think of it like that. Okay, so let's write this out. So I have x is equal to, and I have a -1 over 4 times 2. So -1/8. And then I'm going to have the the y, this is where it gets tricky, y minus 3, be careful here, and then I have -5. So the vertex is -5, +3, and that matches what we have here, so that's the equation there. Okay, the next one opens down, so I know it's y equals -x squared. So I have a vertex at -1, 2. And the directrix, it looks like, is at 1, 2, 3, 4, 5, 6. So at y equals 6. So I'm going from a y of 2 to a y of 6. So that means P is simply 4. but it's going to actually be negative because it's opening down. So let's put everything in place. So y equals a negative 1 over 4 times 4. So it's a 16 here. And then this is y is equal to x squared. So here's my x. And I'm going to change the sign here and keep the sign of the 2. So negative 1, 2. Negative 1, 2 is my vertex. And then it opens down and it has a p-value of 4. So that's how you would do that. Okay, let's graph a few. So looking at number 4 here, I'm going to first of all recognize this one's going to open downward. And it's going to be a plus 0 there if that kind of helps you out. So the vertex here is 3, 0. So 3, 0. And it's going to open downward. My p is going to be 1 over 4 times a. So this is going to be a negative 1 over, and this will simplify down to 1/2, which is going to just be a 2. So p is a 2. So that means I'm going to go down 2 to find my focus, up 2 to find my directrix, because remember we'd already said this one must open down. So then I need my focal width. That's the other thing that's kind of hard. If p is 4, if p is 2, the focal width is going to help me guide the shape of this. It's going to be 2 times 4. It's always 4p, which is 8. So from the focus, if I want it to be 8 long, I have to go 4 to the right and 4 to the left like that. And that gives me the overall shape of that graph. Okay, let's do another one. So I'm going to start by subtracting the 2, basically moving the 2 over, because that's the way we have basically learned this. So the vertex is going to be negative 2, positive 1. So here's my x, there's my y for the vertex with that. And this is going to open to the right. So I'm going to go to negative 2, 1. And there's an understood 1 out front, meaning my p is just 1 over 4 times 1, or 1/4. So p is a tiny little movement, and because this one opens to the right, it's going to be right inside. And if I take the 1/4 times 4 to get the width, it's a really narrow little opening here. So it looks something like that, and my directrix would be 1/4 on the other side. So it's kind of hard to find, but it's something really skinny like that. Okay, so I hope this is helpful. Let's do a couple more down here just to make sure you understand it. These get a little bit harder. They're kind of clues is what I think of them as. Now I have, let's see if one of these looks better. Number 11. Now I have the focus and I have the directrix. So let's sketch that. And this is not one like we've done before. So 3, 5, just kind of eyeballing it there. 3, 5. And then my directrix is at x equals 5. So 1, 2, 3, 4, 5. So it's going to be, let me move this over. It's going to be going right through there, like that. Okay? So this is, you have to be careful. This is your focus. And this is your directrix. And they are going to be 2 apart. So from an x of 3 to an x of 5. Now, that is not p though. The vertex will be halfway between those two. So the vertex is actually going to be located halfway between, so it's going to be 4, 5. So 4, 5. Now what that does tell me is p is a 1. Okay? Also, if this is my focus to the left and there's my vertex, this has to open to the left. So p is going to actually be a negative 1, if you want to think of it like that. So let's write this out. It's also going to be in the form x equals negative y squared. So guys, I like to write this when I start, like just at a high level to understand which parabola I'm even talking about. Is it y equals x squared? Is it x equals y squared? And then is the Lie coefficient positive or negative? And then I can kind of focus in on the details that are kind of more confusing. So if I write out x equals negative 1 over, and it's 4 times 1, so it's just going to be negative 1/4. And then I need the x for my vertex. Nope, sorry, I need the y for my vertex. See, I even have to think about it a lot. So y minus 5 squared plus 4. So remember, outside you always keep the sign, inside you change the sign, and whatever is with the x or the y is the x or y. So in other words, this is with your y, so it's the y from your vertex. So this must be the x from my vertex. So that would be my equation. So I just wanted to make sure that that made sense to you because we had not done one like that. So that should definitely get you going on that worksheet. So hope that helps some for you guys.